Okay, so today we'll be starting with chapter 1.5, which is forces. Just write that down. Right, so forces. A general definition of a force is a push or a pull.
Sir, what about the notes? Should we write all of this down or will you share it later?
Come again?
Should we write all of this down or will you share the notes later?
Well, if you follow, if you're able to follow along, that would be good. I can obviously take screenshots at the end of the class and share them in the group that I've made. Right?
Yeah, that would be better.
That would be better. Okay. In
Yeah.
case I forget to do it, just put in a reminder. Right?
Okay.
So I can do that
Yeah.
later. But do follow along, and also, right after each class or a set of classes, at least on a weekly basis, do review the topic from the textbook. Right?
Yeah.
Also, the way I take the topic the order might be slightly different uh, from the way it's given in the book, right? So there's going to be a topic about springs, right, which is discussed immediately after definition of a force, and I'm going to skip that and get to it later on. I'm not going to discuss it as it is given in the book, right? So just keep that in mind.
Yeah. Okay.
Okay. So a force is a push or a pull on an object, right? That's a very general definition. So if you're talking about a push or a pull, right, there is something else doing the pushing or pulling, right? And right, that can be a physical, physical as in, right, we are talking about physics, so everything's physics, but physical as in more in, a material 3D kind of interaction, right? Or non-physical. So if the type of force is the interaction, the push or the pull between two objects, right? So there are at least two objects involved. And so if that's of a physical nature, then those are called contact forces, right? The non-physical ones are called obviously non-contact forces. Examples, right? So an example could be for a non-contact force is gravitational force, and that is something that we have encountered when we talked about weight, right? So weight is the gravitational field acting on a mass, right? And so weight is a force, right? And it is a gravitational force. You also have magnetic forces and electrostatic forces. And so I'm guessing you have played with magnets at some point or still do. And when you put magnets together, right, at a certain distance, you know that they attract each other and then stick together. Or if the poles are reversed, well, if the poles are the same, right, then they actually push each other apart, right? You can't, right, depending on the strength of the magnet, you can't really bring them together. And so they're exerting a push or a pull, right? So if the poles are different, they attract each other, and so that's a pull. And if the poles are the same, they're pushing each other, but right, they're doing that without actually coming into contact with each other. Right, contact forces examples are friction. Right, and so these forces are basically when two bodies, for example, rub against each other. And that is right what you experience when right you're walking or when you're pushing something across the floor, right, a piece of furniture or a box or something, and the kind of floor it is, the material that's made of, uh, affects how easily you're able to push it. Not, I mean, obviously the mass of the object as well and the size and all of those factors, but right, when you're pushing a box, right, it is rubbing against the floor. Or when you're even when you're walking, or when you are running, or when the car is driving, right, when you're driving a car, so friction comes into play. So those are two, right, physical objects that are coming into contact, and by they're exerting a push or a pull depending on the situation. And right, also, for example, lifting a weight. So that is the image that's given in the text. A bodybuilder uh, is picking up a barbell, right? So first he's pulling it up, and then he's pushing it higher up to raise it above his head. Okay. So with that introduction, right, what do forces do? Well, forces can cause an object to move, to move right from rest meaning that it's not moving, right? So no motion to motion, or if the body is already moving. So for a moving body, right, a force can affect its direction, so it can change its direction. Or speed. And in some cases, right, it can even change the body's, it can also cause a change of shape or size of a body, right? And body meaning any physical, right, three-dimensional object. If at any point, right, you've got any questions, right, just ask. Okay. So, right, we already mentioned contact forces, so that occurs when two objects are touching each other, and they, right, I gave the example of friction, right? Another example, right, is for a contact force. Objects touching, right? So drag or air resistance, right? And these are resistive forces, right? So drag and air resistance, both of these are resistive forces that a body experiences or an object experiences when it is moving through a fluid. Through a fluid. Now, right, they're mentioning when a body is moving through a fluid, and we're talking about air resistance, right? So we can understand if you're moving through water and you're experiencing, right, sort of resistance when moving through water, that's a fluid. But air, yes, well, air is also a fluid because in physics, right, fluid is used for, right, anything that floats. So if I give you the simplified definition, right,
Is it getting a little hard to understand the writing?
the writing,
Yes.
okay, sorry about that. Uh, right, and you know, I know it doesn't justify it, but you will get used to it eventually. But I will try to write more neat. So a fluid in physics is a substance such as a liquid or a gas that flows. Right, so basically it moves about. So in that case, right, air in that sense is also a fluid.
Okay.
Okay. And so what these do, the drag or the air resistance, right? These guys, they act against the direction of motion. Another contact force, right? So that's all they're talking about right now. We'll encounter some of this later on as well. Another contact force is tension. And that is a pull, right? It occurs in a string or it's an elastic force. So it occurs in a string or a spring that is stretched. Then you've got thrust, which is a driving force. And that is a sudden force, right, in a particular direction. So that's just an introduction of the different kind of forces that come in, and right, some of these we will encounter later. Some of them are just given as information. Now, the forces that act on a body or an object are represented in what are called free body diagrams. So they represent the forces acting on an object. And with that, I will move to right the topic of forces and resultants. right? And we'll also encounter a free body diagram.
Sir,
Yes,
could you explain the free body diagram again?
I'll show you a free body diagram, right? So when we're discussing force and resultants, and so that will clear up.
Okay.
Now, one thing we need to keep in mind that a force is a vector, right? And vectors, as we've talked about earlier on, right, are physical quantities with both magnitude, so how big it is, what the size of the physical quantity is, and a direction. Right? And so when drawing free body diagrams, so coming back to right, the free body diagram, the way it's drawn is the forces are drawn with straight line, they're represented with straight lines. Right, with an arrow to show its direction of action. So for example, if I make a very crude drawing over here, right, let's assume that this is a table and you have an object over here. Right, now it could be a container, it could be a book, whatever you prefer. Right, distinguish it. And we know that all objects have a mass, and if they have a mass, they have a weight. And because, right, the weight of an object is due to the gravitational field, in this case, the gravitational field of the Earth, and right, that is directed towards the center of the Earth. So the weight of all objects, right, in this case, whatever this is, let's say it's a book, and so it is, right, acting downwards. So a straight line with an arrow to show its direction. So that's the weight of the book. Now, again, usually there's more than one force acting on an object. And another thing which will come in later, right, is that forces act in pairs. So in this case, the book has a weight and it's placed on a table. Right, and so the table is experiencing the weight of the book. And what's happening is that the table is exerting a force onto the book in the opposite direction. Okay. Now, what this is called, we'll talk about it when we talk about Newton's laws of motion. But just keep in mind that, right, so you're sitting on a chair, and so your weight is acting on the chair, and the chair is also, exerting a force back onto you. So what's happening is that, right, when you're considering these forces, you will look at the magnitude, obviously, of the force and the direction in which it is acting. And you will put them together. So for example, the weight of this book is, I don't know, 5 newtons, right? So it's half a kilo because right, it's mass, in case of weight, it's mass times gravity, right? And acceleration due to gravity, and acceleration due to gravity is 10. So the mass has to be 0.5, right? And so you've got 5 newtons. So it's, right, half a kilo is the mass. And so because the fact that it's easily resting on the table is also exerting a force of 5 newtons back up on the book. And so what you do is, right, you check the magnitude, you check the direction of a force, right, you put them together, and the way you do that is you see whether the direction is the same, and so you just add them up, right? And if the direction is different, then you have to subtract them or take the difference. So in this case, you've got 5 newtons acting in one direction, and you've got 5 newtons acting in another direction, and what you have is 0, right? What you get after either adding them up or taking the difference between them is called the resultant. And in case the value is 0, right, we say that there is no result. Are you following along?
Yes, sir.
Yes.
Okay. So there's no resultant. And, right, when there is no resultant, there is no movement. And in this case, the forces are called, right, balanced forces, because they're balancing each other out. In case the forces are not balancing out, in which case they would be called unbalanced forces. An unbalanced force, that is what a resultant is. So the illustration that is used to explain that is, for example, there's a box, and in one particular case there are 2 forces acting in the same direction on that box, right? So there's a 3 Newton force and there is a 4 Newton force, and they're both acting in the same direction. And so in that case you will add them up and you will get a 7 Newton force acting, in this case, to the right side. Right? And if they are acting in opposite directions but they're not evening out, so let's say, right, there's still 4 newtons here, and this 3 Newton force is in the opposite direction, and so what you're going to get is 4 minus 3, and that's only 1 Newton, but still you have, right? So this is a result, this 2.
Yes, sir.
Okay, so these are called resultant forces or an unbalanced force. And, right, because the topic of motion is, right, included here under forces, and so it is an unbalanced or resultant force that causes motion or an object to move. All right.
Yes, sir.
Okay. So what they do is, right, they talk about engineering and how when structures are built, consideration needs to be taken for all the possible forces that will be acting on whatever is being built. So they give the example of an oil rig, an oil platform offshore in the sea. And so there are so many forces acting over there, right? There's the wind, there's the sea, obviously, right? There's the movement of the earth, the weight of the structure. And so what they do is that they take all of that into consideration and they need to plan it out such that in this case, there is no resultant, right? So for buildings or for any structure, because if there is a resultant, that object is not going to stay stable, right? In those cases, there will be issues of stability. And again, for the example of the oil rig, right, in the sea, if the forces are not balanced, and again, you can expand this to any structure, right, or there is a resultant, then the oil rig is not going to hold, right, and the sea gets rough, right, it gets stormy, the winds blow at very high speeds, and so the structure will end up collapsing, and that's going to not only cause monetary loss, but it will endanger lives as well. So, right, obviously the calculations are uh, much complex, right? But that is something that is taken into consideration.
Yes, sir.
Okay, that brings us to the laws of motion, and we're going to start off with Newton's first law. All right, so the laws of motion, there are three laws of motion attributed to Sir Isaac Newton. And from what we have understood so far, right, the first law of motion states that an object at rest, it's slightly different from back when the wording slightly different from back when I did my O level, but the concept is obviously the same. So an object at rest or in uniform motion, right? Uh, let's redo that. An object stays at rest or continues to move with uniform speed in a straight line, with constant speed. So continues to move in a straight line, right, at a constant speed, unless acted on by a resultant force. Unless acted on by a resultant force, right? And that is basically an unbalanced force. Now, what I need you to focus on over here is they mention that stays at rest, sure, okay, fine, or continues to move in a straight line at a constant speed. Now we've done this, right? Why will it keep moving in a straight line? Because you need a force to change direction. right? We just talked about it. And it will keep moving at a constant speed, which means it is not accelerating. Right? Means no acceleration. Why? Because you need a force to change the speed. And hence, right, you need a force to cause acceleration. And that is actually, one of Newton's laws of motion. So we'll come to that. And along with this, right, so this is definition of Newton's first law. And they also gave a definition of resultant force along with that. So resultant force, right, may change the velocity of an object by changing its direction of motion or its speed. Right, so that's the definition they're giving in the book. Right, so I'll just write that down. A resultant force may change the velocity of an object by changing its direction of motion or its speed. Again, I want you to note over here that they're using the term velocity, right? Because the difference between speed and velocity is that speed is a scalar quantity, it just has magnitude, and the direction is not, I would say, taken into consideration, right? Just how fast the object's going, not where it's going. And
Yes.
right, velocity is a vector quantity, so it is how fast is something going and in which direction it's moving, right? The direction of the motion. And so, right, that's why they mention that it changes the velocity by changing its direction, right? Or its speed, obviously. So, right, but the direction of motion. So that's why they've used the term velocity over here, because it's a scalar quantity. Okay. Now, right, something we understand from this, right, the fact that there are forces like friction or air resistance, which you talked about, right, and these are resistive forces, so they resist motion. And right, they, for example, friction, right, is actually useful, right, because friction or air resistance, right, so when a car is moving car experiences both, right, so friction with the tires and the ground or the asphalt or the tarmac or whatever you want to call it, and air resistance, right, for the entire car. And you can understand, you could say their usefulness is if you have a car in motion and then you just happen to switch the engine off. And so depending on the speed, the car will slow down and eventually stop. And that is because of both of these, right? This also tells us that depending on how much resistive forces are in play, right, the magnitude of force required to move an object. So the more resistive force something is experiencing, right, the greater the force you will need to apply to get an object moving or keep it moving. Right. So in the case of a car, in the case of a car, uh, it is the engine that is providing that force, right? The acceleration, you press on the pedal, and right, it generates that force in the engine, which transfers to the tires, and right now I'm obviously guessing, given your ages, you haven't driven a car, but you ask anyone who's driving, or you may have experienced it even as a passenger, depending on the terrain that you are driving on, the car seems to move, more sluggishly or more smoothly. So if you're driving on a made road, as opposed to if you're driving on, sandy terrain or rocky terrain, right, you can experience the difference because the friction of each of these terrains uh, is different. Also, if for example, again, right, if you're pushing a box and you have a rough surface that you're pushing it against, or any object, right, you have a rough surface and a smooth surface, which one will it be easier to move the box on?
The smooth surface.
Smooth surface.
Yes, obviously, right? And simply because it has lesser friction. And this is, applied, uh, right, when, for example, moving parts are lubricated in engines, right? Or in other machines, they apply grease or oil in machines or any mechanical instrument to lubricate it. And so what that does is it reduces the friction between the parts that are pushing or rubbing against each other, right? And it's also used, for example, in a vehicle uh, called the what was its name? Just a minute. A hover scooter. So what happens is that it generates, right, a cushion of air between the scooter and the ground. And so because the scooter is not actually, rubbing against the ground, not so not rubbing against the ground because of that cushion of air, and so very little force is required to move it. And in that case, because we're talking about a vehicle like a car, even, right, uh, to generate that force, the engine needs petrol, right, and it burns that petrol and converts that chemical energy into, right, the force. And so that would mean that less energy is required to achieve movement, right? And so these are all the concepts, related concepts, that, right, we need to understand. And so when we get a question, they can mix all these things up and ask you to, give reasoning for why something's happening the way they presented it. Clear so far?
Yes, sir.
Yes.
Okay. Okay, next is a very short topic called mass and inertia. And this is just for O level. It is given in the IGCSE textbook, but as, something for a going further topic. So it is beyond the syllabus. Right? It's not even the extended syllabus, it's beyond the syllabus. So it's there in the book if you want to read it, but it's not part of the syllabus. All right, so you can go grab a snack. So what, right, was deduced based on the first law of motion is that, right, all matter has a built-in opposition to being moved. That's what they're saying, right? So all matter has a built-in opposition to change in their movement. What that means, if an object is at rest, it will want to stay at rest, right? And if an object is in movement, right, then it will want to continue to stay moving. So, right, and this property, so it's going to, right, oppose a change in its motion or a change in its state of motion, and this is called inertia. So an example is, for example, right, you are in a moving car. And the car comes to a sudden stop, right? There's a cat on the street and the driver had to apply emergency brakes. So there's a sudden stop. And so what happens is the passengers actually lurch or, are, thrusted forward. Have you experienced that?
Yes, sir.
Yes.
And so what's actually happening is, because the car is moving in a certain direction, even though you're seated in the car and you're not the one moving, so to speak, and so even though you're not moving, you're seated in the car, you are actually moving because the car is moving and you're inside the car, so you're also moving.
Yes, sir.
And so when the car suddenly stops, right, you, because you were in motion as well and there were no brakes applied on you, you will, be thrust forward because that was the state of your motion, right? And that is why, right, you will only stop because something will stop you, right? Some force. So, right, if you're wearing a seat belt, that's what's going to stop you, or you're going to bang your head or your body on the dashboard, which will be very unfortunate, right? Or in some cases, right, you will be launched out of the windscreen, right? And those are the,
Yeah.
right, accidents that happen, and that's why wearing seat belts are important for safety, right? It is actually to combat the effect of inertia, right?
Yeah.
So that is an example of a moving object that has to stop suddenly, and so it will try to keep moving. If you take the similar scenario of a car at rest, and if it suddenly starts to move, in this case, you are pushed backwards. And the
Yes.
concept is the same because you were sitting and the car moves forward, right? And so you were stationary, right? And so when the car suddenly moves forward, you are pushed back, feel a push back, right?
Yes, sir.
And that is because your body wanted to stay at rest. Obviously, an unbalanced force acted on it. There was a resultant force in which the car moved, and being inside the car, you also, get into motion. But there is that resistance. Other examples of, inertia and mass, right, is, for example, You've seen those videos where people pull the uh, tablecloth from under all the dishes on the table and the dishes don't move,
Yes.
right? So pulling a tablecloth, that is inertia. So it's a neat trick, and the physics behind it is what we've just learned. So if you do it fast enough, right, with a quick tug and a forceful tug, depending on how heavy those objects are, you don't normally do it with filled dishes of food because, right, that's where the mass comes in. So I just mentioned that. And so if it's just empty containers, so glasses or plates or cutlery or whatever, and so you'll be able to pull the tablecloth without moving all the other things that were on top of it. And that is exactly because of inertia, because the glass or the Tupperware or whatever else is on the table will resist motion. It's not something you would normally do, obviously, but that's the concept behind it. How does mass play into it? Right, so we know, right, the greater the mass, the greater the weight, right, and that's a force. And the greater the weight, the greater the inertia the body will experience, right? So if
Yes,
it's
sir.
an if an object of less mass, which means less weight, is in motion and it stopped, it will experience less inertia in that case. Or if it is at rest and it is put into motion again, it will experience lesser inertia, right? But if an object of higher mass, right, is suddenly stopped when it's in motion, it will experience greater inertia, right? And that in some cases can be detrimental because the inertia can actually cause damage, right?
Yes, sir.
Because that object still wants to keep moving, right? And similarly, if it's at rest and you wanted to get it to move, you will need to apply much more force to get it moving because it is resisting, right, its change in state of motion. Clear?
Yes, sir.
Yes, Fatma? Ibrahim?
Yes, it's clear.
Okay. So tomorrow, right? Because if I start the next topic, I won't be able to end it quickly enough, and right, that won't be to anyone's benefit. Tomorrow we will talk about Newton's second law. This topic is part of the extended syllabus for IGCSE, so it is part of your syllabus. And obviously, right, we don't have any extended syllabus in the O level, so it's all part of the syllabus. Keep in mind that what we'll talk about tomorrow is also Newton's third law,
Okay.
uh, and that is not in the IGCSE syllabus at all, right? It's not mentioned in the IGCSE book at all, right? But it is in the O level, and so that is something that I will be covering tomorrow. And we'll see how much we're able to progress. We'll talk about friction perhaps, right? And see how far we're able to get with the content. Any questions?
No.
All clear, all good? Rahim, Sobia?
Yes. Yes.
All right. Then I'll see you guys tomorrow.
Okay.
All right.
Sir, is this still recording?
Yes.
Okay.
Okay, love.
Allah Hafiz.
I just wanted to ask something. That's why I